And so this is a string problem where we have two masses tied together. There's a total force of 8.6 newtons applied to this, pulling them along. And it doesn't really tell us where this force is applied. So is it the 2.4 newtons, somebody's pulling on that, or are they pulling on this 2.4 kilogram block, or are they pulling on this 1.3 kilogram block? What we're told is that the net force, the applied force is 8.6 newtons, and we want to know what the acceleration of the system is. And so if this is the overall applied force and it's a frictionless system, then 8.6 newtons must be equal to the sum of these two masses, which is 3.7 kilograms, times the acceleration. And so the acceleration of the system is going to be 8.6 divided by 3.7. And so the acceleration of the system is going to be 2.3 meters per second squared. And so that's the whole entire system. Now, this is question number 40. It goes on to say, calculate the force acting on the 1.3 kilogram mass. And so we don't know if this is being pulled this way and there's tension in the string reducing the force, or if the big block is pulling the 1.3 kilogram block along and it's only the force of tension that's accelerating it. But the thing is, it doesn't actually matter. This whole system is accelerating at 2.3 meters per second squared. And so we know that the net force that's acting on the 1.3 kilogram body has to be equal to the mass times whatever the acceleration is. And since we know the mass is 1.3 kilograms and we know the acceleration is 2.3 meters per second squared, well, we know the net force then is 1.3 times 2.3. We know that the net force on that block is 3 newtons. And so we don't know if somebody's pulling with 8.6 newtons of force out here and the force of tension this way is 5.6 newtons. That's a possibility. Or maybe that somebody's pulling with 8.6 newtons in this direction and the force of tension is only applying 3 newtons. It doesn't matter. As long as we know F net, we'll know, and the mass, we can calculate the acceleration.